So today we're going to wrap up the last bit of inverse trig functions for secant, cosecant, and cotangent. So these are all of the reciprocal functions from everything we talked about in your inverse trig packet that we've been working on for the past 3 days. So some of the stuff is going to kind of come back, but let me just kind of start it off and then we'll see what things are very similar. Okay, so it says first, graph the inverse cotangent function and state its domain and range. Okay, well, I did you a favor and I already graphed the cotangent graph. I want you to think back to when we actually looked at cotangent when we were graphing it out. I graphed out the original tangent graph, and one of the questions that we were actually looking at in this packet was cotangent. So cotangent, this is your cotangent parent function, has asymptotes along 0 and pi and pretty much every interval after that, so about a distance of pi. It'll start to repeat itself. Unlike the tangent graph, cotangent decreases, so it's kind of like going down. So on this graph, you have your cotangent is going down, it's decreasing, but you have asymptotes all of these places that I'm marking it in green. So you have all of these asymptotes. With those asymptotes, remember, we need to create an inverse trig function, and what that does is it means that we're going to have to find an interval kind of close to the origin or close to the y-axis that will be 1-to-1, which means it must pass the vertical line test and the horizontal line test. Well, all of these technically would pass the vertical line test, but the horizontal line test, it wouldn't. If you want to pick something close to the y-axis, I would suggest probably picking something in this interval, for instance, between 0 and pi, because you have, if I just restrict it to between 0 and pi, it would pass the vertical line test and the horizontal line test. So in this space over here, oh, before I do that, cotangent is the reciprocal for what function? Tangent. So in the space over here to the right, let me go ahead and redraw that. So I'm going to redraw just that restricted area for tangent. We're at 0, which is an asymptote. We're at pi, which is another asymptote. And if you think about where that y-intercept is, this x-intercept, this x-intercept is at pi over 2. So I'm going to mark pi over 2 on my graph over here. I'm going to put that little dot for my x-intercept, and I'm going to curve this down and then curve it up. I could get exact points, but we already did that stuff a while back. So let's just first talk about your domain just for this function itself. Chelsea, what's the domain for this green graph? What's your domain for this green graph? Start from left to right. What's the domain? Zero to pi. Can you include it if it's an asymptote? No, you can't, because asymptotes mean you're going to get very close to those values but never actually touch it. This is a pi. Okay, go ahead and give me the range for this as well. What's the range? Look at the bottom of the graph and the top. All real numbers. It's going from negative infinity to positive. So we already know, based on inverses from what we've already talked about, whenever we graph the inverse, literally the domain and range are just going to switch. We're just going to rewrite those, but switched where the range becomes the domain becomes the range. So we talk about how to graph this out. These asymptotes will stay asymptotes on my inverse graph. So at 0, which is now the x-axis, and at pi, which is, again, well, not really on the x-axis, but it's now along the y-axis, these will be my asymptotes. I meant to graph this in a different color, but it's okay. And then for pi over 2, that's still going to be your x-intercept. In this case, though, for inverse, it's going to be your y-intercept because you're literally switching it around. This point is at pi over 2, 0. You guys told me, back when we were talking about the inverse function originally, you guys told me, switch the x and y coordinate whenever you're graphing the inverse. So instead of graphing it at pi over 2, 0, we're switching it around to 0, pi over 2. Just to look at the graph, make an observation. As it gets closer to the asymptote, the y values, which are the along the y-axis, are getting negative, so they're getting bigger on the negative side. So as I kind of curve this up towards my asymptote, where pi is, I'm going to make this closer and closer, but it's going to go down the x-axis towards negatives. And then for the other side, I'm going to look at the same thing. It's going to get close to your asymptote at 0, and it's going to curve up towards where your positives are. So all those positive x values. I just want to confirm, give me a nod or shake. Is your domain, if you switch the domain and range here, is your domain for this graph all real numbers again? Yes, this one's all real numbers. What's the range though? Is it still going to be from 0 to pi? Yeah, if you go from the bottom of the graph to the top, it's only going to be between 0 and pi, and you're not including those endpoints. So this graph in this greenish blue that I have in the middle, this is your inverse tan function, or inverse cotangent. So cotangent inverse. That's my graph. So in the space below, I'm going to talk about a couple of things, and then you guys are going to do some questions with it. So the first thing that it says is, for what values of x is cotangent inverse of cotangent of x equal to x? Okay, well, keep in mind, this x, if cotangent's right next to it, needs to be an angle. Okay, well, this is pretty much doing what we did in the boxes on your inverse, tan, cosine, and sine page. If you have, for instance, an angle, you want to make sure it's in between your range that you have on your graph. So for this range, we want it to be between 0 and pi. Those are the x values you want it to be, between 0 and pi. If you were to graph this out and look at it in terms of quadrants, what quadrants would these need to be in if it's between 0 and pi? 1 and 2. So it's going to go from 1 to 2, and we're not going to include 0 nor pi. So 0 and pi we're not including. Every other angle in between, though, we can include. This is in quadrant 1 and quadrant 2. For the next part, the question mark is in the wrong spot. For what values of x is cotangent of cotangent inverse x equal to x? Question marks behind that. So this x needs to be a ratio. Cotangent inverse helps you realize that you need to have a ratio here. So the only values that you can use where you could actually find it need to be technically all real numbers. So it could be from negative infinity to positive, which is the same thing, guys, as all real numbers. So let me kind of clarify this. If you have, for instance, a ratio that's between negative infinity to positive, you can just cancel out the cotangent and cotangent inverse. You can just cancel those. If you have a value for your angle that's between 0 and pi, and it's not including 0 and it's not including pi, you can cancel both of those. So that rule still applies even for the reciprocals. It's the exact same thing. So I'm going to do two things before we actually answer each of these questions. First thing I want you to do is I want you to label what are the numbers I'm underlining. So for instance, for 1, Joseph, what is this? Is this a ratio or an angle? It should be a ratio. For 0, okay, technically 0 can be a what, Joseph?
Ratio. Or an angle.
Or an angle. Technically be either one. So that's when we actually take a look at cotangent inverse. What should this be if it's cotangent inverse? Should be a ratio. Go ahead and do the other two. What's this one?
Again, ratio.
A ratio. And the last one, 5 pi over 3? Should be an angle. So just like how I checked to make sure that this matched up with your ratio or angle that you have, we're going to go ahead and do that for the other ones. 0 is the only exception where you kind of need to look at the trig function first. So cotangent inverse of a ratio, that works. I can actually solve that. We said cotangent inverse before. We could solve that if it's 0. Cotangent inverse of a ratio, yes, we can solve that. Cotangent, notice that cotangent is here, of an angle, we can solve that. I know it's a composition, but we'll worry about that in a second. Again, before I start solving anything, I want to give you guys the groundwork. So down here at the bottom, I want you to create your unit circle chart, specifically for cotangent. The issue is we've only memorized 3 things for your unit circle chart. We've only remembered sine, cosine, and tangent. So what I want you guys to do is recreate your unit circle chart. And I want you to write tangent, because you already have tangent committed to memory. And we need to figure out how to find cotangent of theta from here, or cotangent of x, because theta and x are just an angle measure. I just wrote this at the top. Cotangent of theta, or cotangent of some variable x, is the same thing as 1 over tangent. It's literally just the reciprocal. So down here at the bottom, I'm just going to rewrite this as 1 over tangent of theta, which technically means the same as cosine of theta over sine theta. I don't know if we're going to need that, but if you need it, guys, it's here. So all I need to do is take each of these tangents and put them in your denominator for this fraction to create cosine. So for instance, for the first one, this is going to be 1 over 0. Eurydia, what's 1 over 0 simplified to? Not 0. This one's undefined. For square root 3 over 3, okay, I'm going to need some space. 1 over the square root of 3 over 3. What are you going to have to do here, Euridia? Yeah, keep, change, flip. We're doing the 1 over 1 times the reciprocal, which is 3 over the square root of 3. If you multiply this out straight across, it should be 3 over the square root of 3. Euridia, you know how I am. I'm not going to let you keep the radical in the denominator. What are you going to have to do? Rationalize. So you should get 3 square root 3 over 3. Do I write that as my answer? What can I write instead? These 3's cancel. All right, for the next one, Euridia, 1 over 1 is just 1. So if I was to make 1 over 1, that's still 1. 1 over the square root of 3, you're going to have to rationalize like we did before. So let me double check. This will be square root 3 over 3. And Euridia, if something's undefined, does that mean that this will be undefined too? Maybe. What does undefined mean? What do you have in the denominator? You just told me for the first one. A 0. So this is the same as something like 1 over 0. If you were to make that into a fraction, I'm running out of space, but I'm going to make it work. I have 1 over 0, because you just told me that's tangent, right? If you were to keep, change, flip for this, you'd have 1 over 1 times 0 over 1. What do you think that would simplify to? Just 0. Just 0. So over here for pi over 2, we're going to make 0. Guys, for secant and cosecant, I'm going to have you guys do the exact same thing. I'm not going to hold your hand through it, but you can easily create this, this chart on your own, this table. All right, so let's go back to the questions at the top, and we can now answer them. So for the first question, it says cotangent inverse of 1. David, look at your chart down here. When is cotangent, what angle measure will cotangent be if it's going to be equal to 1? Pi over 4. Let me ask you this. Is that my only answer that I could use? Is that my correct answer? What do I do? Remember, we did this before. No, go ahead. Okay, so let's graph this out. Here's pi over 4. It's in quadrant 1. Quadrant 1 is in my range, so this looks good. Where would it show up in quadrant 2? At pi over 4, what sign would you have for cotangent? Would it be positive or negative in quadrant 1? Cotangent would be positive. In quadrant 2, what would 3 pi over 4 be? Negative. Look back at the question. Am I going to keep both answers, just one? Which one? The first one. You're not going to keep both answers. You're only going to keep the first because the answer is positive and your 1 is also positive. But it is good to at least see what other numbers you have just in case. All right, for the next one, right next to it, if I was to write out what your answer is for this, we have cotangent inverse of 0. It's just a ratio. So if I look at my graph, cotangent of 0, the angle measure will be pi over 2. Okay, let me look at my unit circle chart. You don't have to, but it'll help. For pi over 2, that's up here. That's in between the interval we were talking about, between 0 and pi. The only other place you're going to get a cotangent of 0 is down here at 3 pi over 2. Is 3 pi over 2 in your range that we were talking about? No. That would be your answer, just pi over 2. All right, for the next one, cotangent inverse of negative square root of 3. Heidi, what should I probably use to help me with that negative square root of 3? Okay, so we have our chart. So what is cotangent inverse of negative square root 3? Say it again. Pi over 6. Is that my answer? It could be, but what do you notice about this pi over 6 for cotangent? It's positive. Over here, though, for our question, it gives us negative. So I like that you found that this cotangent here is positive, but I need to find out where it's negative. We know that it needs to be in between quadrants 1 and 2. So tell me, where is pi over 6 going to show up in quadrant 2? 5 pi over 6. And at 5 pi over 6, is cotangent going to be positive or negative? Cotangent's going to be negative. So over here, I'm going to write my answer as 5 pi over 6. Guys, it's the same thing we've been doing. I'm just having you look at a new set of restrictions. That's all. Jenny, please tell me I can just cancel the cotangent and cotangent inverse. Can I cancel that? That's a shaky yes. Let's graph this out. What quadrant is 5 pi over 3 in? We have 0. We have 3 pi over 3. This will be 6 pi over 3. Quadrant 4, there you go. 5 pi over 3. Is quadrant 4 in my range that we were talking about up here? Okay, so we need to figure out where will this angle measure show up in quadrants 1 and 2. So technically put a little X next to this because I can't really solve it if it's, or I can't just cancel it if it's not in quadrants 1 and 2. Okay, so it is an angle next to it, which was nice, but it's not going to be in quadrants 1 and 2. Where will 5 pi over 3 show up, Jenny, in quadrant 1? What angle would you reference here? Pi over 3, perfect. Okay, pi over 3 though, if you think about 5 pi over 3, let's start here. What sign is cotangent in 5 pi over 3? It's negative. In quadrant 1, what sign is it? Okay, well, we can't use positive, right? This is tangent, that's positive. Can't use pi over 3. The only other place I could possibly use is in quadrant 2. If I can't find an answer here, it's going to be doesn't exist. So what's the angle measure we can reference here? At 2 pi over 3, Jenny, is cotangent going to be negative in this quadrant? Yes, cotangent is negative. So my answer is 2 pi over 3 for this question. Give me a nod or shake. Does this make sense? Because these are the only questions I'm really going to work through in detail with you guys. The next couple ones on the next couple pages, it's just using the same process we've already talked about. The only difference is we're going to have different sets of ranges, different factors. All right, last chance. Any questions? If you're good and you're ready to move on, flip it over to the next page, please. All right, so we have a couple of other graphs to look at, specifically where your restrictions will lie. So we have our next graph, which is cosecant. Jesus, what's the reciprocal for cosecant? Is it sine or cosine? Say it again. Cosine. Cosine of x. That's your reciprocal. So if you think back to when we actually graphed this, secant, we actually graphed the cosine graph first, and then we created our secant function. We literally just did this. I'll pull it up really quick. On our notes here. When we graphed secant, we had the original curve for cosine, and then we graphed our actual cosecant, or secant graph. I don't know why I can't say that today. Okay, so let's look at the graph. I noticed that when I looked at my packet that I had asymptotes at negative pi over 2, positive pi over 2, and these intervals were about pi units before it went to its next asymptote. So over here, I'm going to make my asymptotes. As of right now, if I was to try to make this graph pass the vertical and horizontal line test, it wouldn't do it. It wouldn't be able to pass. So I need to figure out, I need to restrict this domain somehow, but I need to figure out where. Valerie S. I always told you guys, focus closest to the origin. All of this that I have within your window is one full cycle. Will this pass the vertical and horizontal line test as it is right now? No. Okay, so let's go in a little bit further. If I was to restrict it into here, would this pass the vertical and horizontal line test? Yeah, it wouldn't repeat. You tell me, with that interval I have, I'm going to scoot out just a bit. What's the interval for that along the x-axis? Between what and what? 0 and pi. So that's where we're going to restrict our domain here. So over here to the side, I'm going to redraw this, and I'm going to restrict it from 0 to pi. So here's 0, here's pi, and at both of those 0 and pi's, I don't have an asymptote, but I do have an asymptote at pi over 2. And this is for y equals secant x. This is just your restricted area. Okay, let me double check. If I'm starting at 0, it has a y-intercept here at 0, 1. So let me put 0, 1. Here's my y-intercept. On that curve, it curves up towards the asymptote, and notice that those values are going to increase. So it's going to curve up towards the asymptote, and your y values will increase. Down here at pi, negative 1, which is where we were told to stop, pi negative 1 will be our next point, and this is going to curve down, again, towards the asymptote. So I'm just curving it down towards your asymptote. Valerie, what's the domain for this graph? Read it from left to right. What's your domain? Start from the left. Where is it starting on the x-axis from the left-hand side? 0. And where is it going to? Pi over 2. At pi over 2, what happens? What do you have? Asymptotes. We're going to put a parentheses, union, go to the other side. We're going to start at pi over 2 again, because we need to go to the other side of the asymptote. And where's it going to go from there? Pi. I'm going to also label the range for this. Is the range all real numbers? No, it's not. You have a huge open space in between -1 and +1. Guys, labeling domain and range is what you did back in Algebra 1. So this should just be from -infinity to -1. Union, at the bottom of this, we're going to go from bracket 1 to infinity. That's your range. So with this domain and range that I listed, we're going to switch them for your inverse graph. So over here in the middle, I'm going to do this in purple. We're going to make the secant inverse of x. Okay, so let me label the points I have. I have 0, 1, I have an asymptote, and I have pi, -1. You guys told me when we first did this that if you switch the x and y, you'll be able to get your inverse graph. Your asymptote is still going to be at pi over 2. So at pi over 2, I'm still going to have an asymptote. It's just along the x-axis now. And I'm going to switch my points around. Okay, 1, 0 is now going to become, okay, well, I don't have a space for 1, so let me put 1 here. Here's -1. At 1, 0, we're going to have our point, and it's going to, the x values, or excuse me, the y values increased as you got closer to the asymptote. So the same kind of process is going to follow. Your y or your x values this time are going to increase as you get closer to your asymptote. Same thing for the other side. At pi -1, this the y values along the y-axis were getting smaller, and it got closer to your asymptote. So we're going to do the same thing up here. We're now going to make it -1 pi, and now our values are going to continue to get smaller and smaller, but they're going to get closer to your asymptote. So the y values, or excuse me, x values get smaller. Carlos, what's the domain for this? Read this from left to right. What's your domain? Not quite. Does it include all the numbers in between -1 and positive? Do you have anything connecting this? Because this asymptote doesn't count. Yep. That's it. There you go. You can, it's almost all real numbers. You just have to include that big gap that you have between -1 and positive. For the range for this, Carlos, what's the range? Go from the left to right. Or excuse me, range, bottom to top. Sorry about that, bottom to top. Start along the bottom of this graph. Where's it starting on the y-axis? Well, let's try it again. Y-axis? At 0. There we go. We're starting at 0. That's a closed circle, 0. Where's it going to? Okay. Remember, we're going to go to the opposite side of pi over 2, and where's it going to end at? Pi. So that's our domain and range. So the same thing follows like we had down here. I'm just going to draw this out. When you have secant of some angle, so this x should be some kind of angle, secant should be right next to it. When you have secant of some angle, your range, which is what we're looking at, should be between 0 and pi over 2, and then pi over 2 to pi. Carlos, one last question. Where would that be on the unit circle if we're going from 0 to pi over 2 and then pi over 2 to pi? What quadrants? And the second one, yeah. First and the second one. Quadrant 1 and quadrant 2. What's the only value we're not including in quadrants 1 and 2, Carlos? No, hold on. We are in quadrants 1 and 2. Here's 0 to pi. We had pi over 2. Are we including that value for pi over 2? No. So we're going to put a big open circle at pi over 2. This pi over 2 is not included. Not included. We are not including that pi over 2. Everything else that's between it, we can definitely use. All right, we're going to label the same thing for secant inverse, and then I'm going to have you guys create your table and do questions 6 and 7. So over here, secant inverse of x, this number needs to be a ratio. Since it's secant inverse, this ratio needs to be between -infinity to -1 and from 1 to infinity. That's your values for your ratios. So all of these ratios need to be between negative infinity to positive, ending at -1 and +1. Right now, the same thing you guys did on the front page is what I want you to do down here. Recreate your chart. 0, pi over 6, pi over 4, pi over 3, pi over 2. This is going to be the reciprocal for cosine because you haven't memorized secant before. I don't expect you to. So cosine of theta, we know that cosine decreases. Like as you count, it's going to count down. I've led you this far. I want you guys to label your secant values. Label all of the items down here, and then answer questions 6 and 7. I'm going to give you about 2 minutes. Remember, secant is the same as 1 over cosine of theta. It's the exact same thing. You just have to actually flip each of these fractions. So, Joseph, what did you get for secant of 0?
1.
What about pi over 6? Perfect. Pi over 4? Pi over 3.
Oh.
And pi over 2. Undefined. Yes, that's exactly it. So these are your values. Okay, so for question number 6, first thing you want to double check is that this is a ratio, which it is. Do you see secant inverse of 1 down here? Yes or no? Yes. Where is secant of inverse going to give you 1? What angle measure would you have to reference? 0. So this is like 0 radians. So notice I'm putting RAD behind it, so that way you know that's technically radians. And then for question 7, secant inverse of 0. This 0, technically with secant inverse next to it, needs to be a ratio. That's what I would suggest doing. If I look down here, I know I have undefined, but undefined is not the same as 0. Do you see 0 down here? Okay, let's take a second and look at this. When your ratio is 0, 0 is a ratio, right? Is that between this range, or excuse me, this domain that we were talking about? These are all the ratios we can use. Where is 0? If you look at your graph, guys, it's right in the middle. Remember that big open space that I kept telling you guys it's not from negative infinity to positive? That's why. 0 would be somewhere in the middle, and you won't have any part of that purple graph anywhere in secant inverse of 0. So what you're going to put down here for secant inverse of 0 is it does not exist. It literally doesn't. There's no part of that purple graph that will ever give you an angle measure. When you're done and you're ready to move on, let's look at the last page that we're going to talk about, which is the next one. All right. For this one, cosecant. Okay, so this is the same graph that we saw when we were actually graphing cosecant. Cosecant is the reciprocal for sine, so I'll actually graph that out in a second, or write that out. And I want you to notice that for the reciprocal, you have to graph out your sine first, and then create that cosecant graph. So, let me go ahead and make a note. This is the same as 1 over sine x. And I also want to make a note that all of your asymptotes are going to be along 0, pi, 2 pi, and even over here on the negative side. Okay, so again, I need to figure out where I can kind of restrict the area that I have, because as I have right now, this will not pass the vertical and horizontal line test. Okay, so let's focus on just one cycle. Okay, one cycle, if you think back to when we were doing this in our notes, we just said it was from 0 to 2 pi, because it needs to have one section that goes up, one section that goes down. Will that work as far as getting me a good domain for this? And actually, I kind of want it closer to the origin, so let me go from here to here, because this is also technically one full cycle. It has one going down, one going up. Fatima, if I asked you to test the vertical and horizontal line test here, would it pass? Okay, so let's go in a little bit more. If I was to just go in about pi over 2, would this pass now? Yes, it would. If I just put it between negative pi over 2 and positive pi over 2, it will work. So between negative pi over 2 and positive pi over 2. Those are the two values I'm going to use. So on my graph over here, we're going to recreate it. This is for y equals cosecant x. We're just restricting it to make it a one-to-one function. We have negative pi over 2, that is over 2, and pi over 2. At both of those, we have a point. So at negative pi over 2, we're going to go to negative 1. And the graph is going to kind of curve down. It's going to get to all of these negative values. So it's going to curve down because you have an asymptote here. Literally just recopying this. At pi over 2, you have a point at pi over 2, 1. And we're going to curve this graph going up towards all of those positive values. So I'm literally just graphing this little window. Valeria, what's the domain here? For this graph, what's your domain? Let's go from left to right. To what? Okay. Are you including 0? No. Okay. Keep going. Perfect. Give me the range as well. I'll tell you right now, the range is not all real numbers. Okay. You said, say it one more time. You said 1 to infinity? Yes, that's exactly it. So remember, for the inverse graph, when we graph this out, we're just going to switch the x and y's, guys. That's all. I want to make a note of what points we have. We have negative pi over 2, comma, negative 1. And we also have the point up here at pi over 2, comma 1. I want you to understand why I'm switching them so I can create my new graph. Your asymptote was along the y-axis. When you switch that around, it's going to now be along the x-axis. Just like the last graph, I'm going to need a point at negative 1 and at positive 1. So I'm going to put a hash mark here for 1 and a hash mark here for negative 1. Okay, let me plot what I have. I have the point negative pi over 2 and negative 1, but I'm going to switch that around to make it negative 1, negative pi over 2. So here's my point. This point needs to curve towards the asymptote, and it needs to continue to go down the y-axis. Well, since I switched it, it's going to be going towards the asymptote, but now it's going to get close to the x-axis since we switched it around. At pi over 2, 1, I'm going to switch that around, so it's going to become 1 pi over 2 for my point. And it's going to get towards your asymptote going up the y-axis, which is now going to be going pretty much to the right of the x-axis as it gets close to that asymptote. Jorge, what's the domain here?
Negative infinity to negative 1 bracket union bracket 1 to infinity.
Perfect. And give me the range as well.
Bracket negative pi over 2 to 0 parentheses union 0 to pi over 2 bracket.
Perfect. With that range that you just gave me, Jorge, what does that mean for your graph? What intervals or, what quadrants should you be looking at? If it's between negative pi over 2 to 0 and then 0 to pi over 2, what quadrants?
4 and 1.
Quadrants 4 and 1. So for this one, let me make sure you guys have this. Cosecant of an angle, this number needs to be an angle, and we just have that number from your range. That angle needs to be between negative pi over 2 to 0 and from 0 to pi over 2. So that's why Jorge told me it needs to be in quadrants 1 and 4. So somewhere between these two quadrants. Remember how we skipped over 0? That means you cannot include 0. So I'm just going to put a big open circle along the x-axis for 0. I'm going to make a note. 0 is not included. Pi over 2, negative pi over 2. And it could be any numbers in between. Don't worry, I'm about to move. This is in quadrant 1 and quadrant 4. I'm going to highlight those quadrants so you can see it. Quadrant 1 and quadrant 4. If you can see it on yours, you don't need to highlight. So now for the ratios. So this number has to be a ratio, especially since it's next to your cosecant inverse. That ratio needs to be in this domain. So it needs to be from negative infinity to negative 1 and from 1 to infinity. Every ratio we have needs to be in this interval. Every angle we have needs to be in this interval. So you guys already know what I'm going to tell you. Recreate your chart down here specifically for sine, since cosecant is the reciprocal for sine, and then answer the two questions. I helped you out with sine. Now you need to create your cosecant. finish this chart, and then answer 9 and 10. Remember, guys, when you're doing cosecant, it's just 1 over sine. So take each of the sine values that you have and put it in your denominator. So put it underneath it and find the values that we just found. Hussein, for question 9, cosecant inverse of 1. What was the answer you got? First, is cosecant of 1 a ratio? Cosecant inverse of 1, is this 1 a ratio? Yes or no? 1? That's just a number. 1's a ratio. And especially since cosecant inverse needs to have a ratio next to it, this is a perfectly sufficient question. So look at the bottom. Where is cosecant going to give you a 1? That is pi over 2. At pi over 2, double check the graph that I made up here. It's a little small, but double check this graph. Is pi over 2 in your range that you can use?
Yes.
Yes, it's right on that line, so you can definitely use it. Let me ask you this. Especially since negative pi over 2 would be down here, can we use negative pi over 2 as well? Let's look at the coordinate. I'll help you out. Look at the coordinate. What would be the coordinate at negative pi over 2? Perfect. And we said that the fraction for cosecant is 1 over sine. Is sine the x or the y coordinate? The y. Okay, well, in that y coordinate, you see how that's negative? Is that what it's asking for, or is it asking for positive? So can we use negative pi over 2? We cannot. All right, good job. For question 10, we saw this on the last question for secant. Does cosecant inverse of 0, does that exist? No, you're having that same issue that we just had on the last question. This answer does not exist. The reason why, this 0, since it's next to a cosine inverse, needs to be a ratio, which means it's just a number. The ratio interval that you need to focus on is this interval here, between negative infinity to negative 1 and 1 to infinity. 0 is literally right in the middle of negative 1 and positive. You cannot find a value ever that will ever exist for that answer. Last thing that I kind of want to mention really quick, if I could flip the page. This back page, guys, you've done worse questions on tests and quizzes, so I'm going to leave you to those. For question 15, I'm not going to go through it, but what are you supposed to do for question 15? Chelsea, don't give me that face. What are you supposed to do for that question? Oh, remember how we created a triangle last class? Yeah, that's what you're supposed to use for this. So how it has in the parentheses tangent inverse of u is in Underwood and c or cosine outside, you're just going to do the same thing we did here. So it's literally the exact same thing. Don't forget about that, guys, because it will show up. I'm telling you, it'll show up on your tests and quizzes and even your final. All right, there's one last thing I want to talk about, and that is the single sheet of paper you picked up when you walked in. So get this out really quick. This is like your reference chart to kind of make sure that you have the correct inverse restrictions and domain for all of your graphs. So for instance, I'm not going to do all of these with you, but I want you to get an idea of what I expect or what I would like for you to do. This is just one page, so you don't have to flip through. Remember that 9-page packet that we were just looking at? This guy? Yeah, I don't want you to have to keep flipping back to this page. So instead, I want you to just look at this page to have all of the information you need. So the domain, these are all of your ratios. If you don't believe me, let me look back. Flip back here. For the ratios, that was between negative 1 and positive 1, so that's why I wrote ratio here. And negative pi over 2 to pi over 2, these were referencing your angles. So I'm going to make a little note here. These are talking about your angle. What, especially for your angles here, what 2 quadrants are those in? Jacqueline, what 2 quadrants are those in if it's negative pi over 2 to positive pi over 2? Not 3. Quadrant 4. Quadrants 1 and 4. And guys, you've already done this in your notes. We've just pretty much writing them on a single sheet of paper. So we have pi over 2 to negative pi over 2. These are all of the values, and this is in quadrant 1 and quadrant 4. What I want you guys to do, these are your notes. Use them how you feel that will help you study the best. But I'm going to give you guys about 2 or 3 minutes. I want you to take this entire page. You can ask the person next to you what they're writing, but I want you to fill this in. Give yourself an honest attempt and an honest try at helping yourself remember this so you don't mess up on your tests and quizzes. So right now, flip back through that big packet of notes that you guys have been doing for the last 3 or 4 class days, and fill this in. This even includes this cosecant, arc-secant, and arc-cotangent, which are the 3 that we just did today. Okay, so just so you know, guys, this is how my reference chart looks. So I kind of, like I said, I don't want to have to keep flipping through all those packets that you guys did. So for instance, in the first one, we already did this one together. For this one here, I labeled my ratio and my angle, and I just said what quadrants it's in. I made sure to put radians behind the 0 because I didn't want to mix this up in the future. Forgot to put the actual quadrants. But yes, I want to make sure that you actually write out 0 radians, for instance, so you don't forget. Same thing here. I labeled out what was included, what was not included, and especially when you have an interval from negative infinity to positive, you can use a ratio, really any ratio. That's why I underlined any. And then same thing down here. I'm just going to go through each of them and label this one as quadrant 1, quadrant 4. That's a 4. Quadrant 1, quadrant 2, and same thing here, quadrant 1 and quadrant 2. It seems easy now, guys, but when you're studying for your tests and quizzes and you're like stressed out because you have a lot of other things you're doing, this will help. So especially for me, this would be the easiest thing for me. So it's up to you guys if you choose to use it or not, but all of this, I'm gonna go from side to side, is everything I have on my chart. You guys make it as detailed as you want.